So we are right here at practicing with standardized values worksheet. It gives me, shh, you guys, I am recording right now. I need you to be quiet. I need you to have this in front of you. Okay. I've got that the mean for males is 68.6. The mean height for women is 63.6. The standard deviation for males is 2.65. The standard deviation for females is 2.5. The shoulder width for males is 17.7. The shoulder width mean for females is 16. The standard deviation for both is 0.85. So it's going to ask me questions about all of these. Okay? How tall is a male with a z-score of 1.6? So we know we're using this formula, and I'm going to write it right next to here again. X minus the mean over the standard deviation equals the z-score. X minus the mean over the standard deviation equals the z-score. So I'm going to plug it in. X minus, I'm talking about a male, and I'm talking about his height. So I'm looking at 68.8. Over the standard deviation, 2.65, equals the z-score, 1.6. And I'm going to now solve for x. So what am I going to do?
Do the times in there.
Yep, I'm going to times both sides by 2.65. And I get x minus 68.8 equals 4.24. What are you asking, Abs? What? Why I'm doing it?
No.
I times both sides by 2.65.
So set it up like x minus.
Yep, so these cancel. Yep.
2.65. And then times both by 2.65.
Yes.
And then you got x minus whatever the heck.
68.8,
And then equals
4.24.
because
1.6 times 2.65 is 4.24.
1.6.
Right here, 1.6, it equals, the z-score equals 1.6. Where are we lost?
It was just a lot.
It's okay. Sometimes you just like to repeat exactly what I say and then you get it. That's all right. Okay. Can't hurt everybody else to hear it twice. I add 68.8 to both sides. Shh. So if I have 68.8 plus 4.24, the male that we're talking about was 73.04 inches tall. 73.04 inches tall. Okay.
So you didn't times 2.65.
Okay. I had, hold on. I had x minus 68.8 over 2.65 equals 1.6, correct? I multiplied both sides by 2.65.
So you don't times 68.
Now then I add, because there's a subtraction sign in front of 68.8, so I have to add it to both sides. Yeah,
Before everything, you don't times.
correct.
Times the x.
Yes. I'm real serious here. I'm going to have Miss Huff escort some of you out of here if you can't be quiet. We can't have this whole conversation. Okay. Number 2 is a little bit complicated because it says, if a female is 5 foot 5 inches tall, 5 feet 5 inches tall, and a male has a z-score of 0.3, who is taller? Relatively taller, like that much taller than the mean, and who is actually taller? So first of all, let's figure out this girl. She's 5 foot 5 inches. How many inches is that total? How many inches are there in a foot? So 12 times 5 is 60. Plus 5 more means she's 65 inches. So now we need to figure out her z-score, and we're going to have to figure out the guy's height because we have his z-score. So we're going to take her score, her height, 65, minus the average for a female, which is 63.6. Divide that by the standard deviation for girls, which is 2.5.
So 65 is the x now.
Yes.
And you would use female.
Yes. Yes. Shh. Gentlemen, shut up. And I get the z-score is 0.56. Which one's is relatively bigger? I know both of their z-scores now. Who has a bigger z-score? The man or the woman? The woman. So the woman's, because hers is 0.56 and his is 0.3. So the woman is relatively taller because she's further from the mean. Okay, now we're going to figure out how tall the man was to figure out who is actually taller. So we've got x minus 68.8, I'm using the mean for the male, divided by the standard deviation for men, which is 2.65, equals the z-score, which is 0.3. So now I have to solve this, but I believe I already did for the one above. It's the exact, no I didn't.
It's a different z-score.
Okay, so it is a different z-score, thank you. So I'm going to go 0.3 times, go by. No, go sit in the back, at least away from me. I can't have you near me anymore. So I've got x minus 68.8 equals 0.795. And then I'm going to add that to 68.8. And I get that the man was 69.6, I'm going to round up, inches. So who is actually taller? So I multiplied this times this. Not give me that.
You did what times what?
2.65 times 0.3 gave me
You don't
0.795.
have to times both sides by each other like you did the other one?
You up there, you did 2.65 times 1.6.
Yeah,
Yeah.
yep. And then I added 68.8 to both sides, giving me 69.6. So who's actually taller, the man or the woman? Man. Man is taller. Okay, so I want you guys to get this though. He's only 0.3 is his z-score, whereas she is 0.56. So she is considered taller for a woman than he is tall for a man. Does that make sense? Even though he's actually taller. Because it's like if the average woman is 63.6 inches, she's much taller being 65 inches. But if the average man is 68.8 inches, he's 69.6. You know, he's like not even an inch away. Where she is like 2.4 inches away. I don't know if we'd say abnormal, but she's not even unusual yet because she's not more than 2 standard deviations away. She's just relatively taller.
We call it gal 5'7" as,
Unusual?
unusual, I'm 5'9".
So if we do standard deviations for that, so we can figure out this for Ms. Huff. So Ms. Huff is, how tall are you? You want to do 5'9"? So she's 69 inches, so if we go 69 minus 63.6 divided by the standard deviation, which is 2.5, 2.16, that is unusual. So,
Normal?
but you are unusual for a woman's height. But 5'9" would not be that. Unusual is outside of 2 standard deviations, and she's 2.16 standard deviations away from me. Huh?
What's the control?
I'm 5'7". I'm 5'7". Okay. That I'm 5'7"? Yeah? I don't know.
Yeah, I'd be happy with myself.
I argue with my husband all the time that I'm tall for being 5'7", so we need to figure that out now. So if I am 67 inches tall minus 63.6 divided by 2.5, I'm 1.36 standard deviations, so I'm not unusually tall, but I'm 1.36 more than the mean.
Right,
So I think I'm still tall.
yes. Are these actual?
No, these are completely, so what does the bottom of the paper say?
I don't know, is
There's little stars. Yeah.
it nice?
So this is,
She's a liar.
McGregor made this up.
yep, you did, Mr. McGregor, Steve McGregor,
I know
he wrote this off. Okay, Jimbo, I don't know why, his name is Jimbo, is a male that has a standardized value of negative 1.2 for shoulder width. Can he walk between two poles that are set 16.5 inches apart without turning sideways? So we're seeing if he can, if he is less than 16.5 inches, which is like that. Okay, so we're going to figure out his shoulder width when we know the z-score. So we're going to go x minus, what is the mean for shoulder width for men? 17.7. What's the standard deviation? 0.85, and his z-score is what? Negative 1.2. Negative 1.2. Okay, so we're going to solve for that. What do we do first?
Oh, I got times 0.85.
Yes, so we get x minus 17.7 equals negative 1.2 times 0.85 gives me negative 1.02. And then I'm going to add 17, negative 1.02. And I'm going to add 17.7 to it. And he is 16.6868 inches, so he cannot walk between them. No, he can't. Because that's bigger than 16.5. He'd have to turn sideways. Okay. Miss Huff and Miss S, can you see if Miss Malbuff is done with her computers? Thank you.
Yeah, I just looked it up. The average male height is 70 inches with a standard deviation of 4 inches.
Okay.
And the average adult woman is 65 inches with a standard deviation of 2.5.
Just in case we wanted to know. What percentage of women are taller than 66.1 inches? So we're going to have to use that to find the z-score and then look up on the z-score their percentage. Okay? So we're going to go 66.1 minus 63.6 all over 2.5. What were you going to ask, Abby? Okay. 66.1 minus 63.6 divided by 2.5 gives me a z-score of 1. So when I look up 1 on my paper, 1, 0, so I go to my z-score, look up 1, 0, I get 84 point what? I get 0.8413, right? And so that's 84.13%. Okay. If I say I have a standardized value of 2.3, we know that means the z-score, right? That's another way of saying z-score. Okay, so we want to know how tall a male is if he has a z-score of 2.3. So we go x minus 6.88 divided by the standard deviation, 2.65, equals 2.3.
Times 2.65.
Yep. And I'm actually going to stop here, and I'm going to have you guys finish the rest on your own. Because I think we've started this pretty good. I think you can do this on your own. And the back is, I'd like you to do as much as you can of the back. If you get stuck on it in the back, we will go on. I just want to see that you have tried the front and the back. Okay? I'm stopping now.